So this video will be an example of establishing an identity, and this one will be a little bit more complicated, I think. Not a whole lot, but a little bit more than the previous example. Um, so let's get started. So we have two basic options. First option is take the whole equation and rearrange it until you get something that's clearly true, like 1 equals 1, clearly true. Then you're done. You've shown that the original is true. An identity, not a conditional equation, as long as you do reversible algebraic manipulations. Um, that's to me that's usually harder, not 100% of the time, but usually that's going to be more challenging because you've got so much more stuff to deal with. I think it's generally easier to just pick one side or the other and rearrange it until you get the other side. Now, that means we have two choices. I could, if I want, start with this right-hand side. But that's going to be harder. Maybe I can illustrate why with a simple example. If I say, I'm thinking of two numbers, all right, I'm going to tell you what they are, and I want you to combine them and give me the result. Well, 8, right? But if I didn't tell you that, and I told you, I'm thinking of two numbers, here's their total, it's 8. Could you come up with 3 and 5, like on your first guess? Well, no, probably not. I mean, maybe, but maybe I'm not telling you any numbers at all, and I tell you that I think of two numbers and their total is 80. What are the chances you could guess the two numbers at the beginning? It's just not going to work. But if I tell you, oh, it's a 45 and 35 are the two numbers, you could work out 80 without too much trouble. So going from something with more pieces and reducing it down is going to be generally easier. Maybe not all the time, but generally easier than starting with the simpler looking version and trying to work out, well, how can I break this up into the right pieces? That's, I think, is generally harder overall. So I'm going to start at the left-hand side. 3 sine squared theta plus 4 cosine squared theta. And what I want to do is I want to use either some algebra or some trig identities, different things in my toolkit, and I want to try to turn this into 3 plus cosine squared theta. And the first thing I notice is I've got a 3 in both places, so that's encouraging, right? We've got 3, 3 is a coefficient here. Hold on. Sorry, struggling with the interface here. I have 3 as a coefficient here, and I have a 3 here. Hey, that's encouraging. That's good. But the other thing I notice, hold on, sorry, struggling with the interface again. The other thing I notice is that there's no sine here. There's only cosine. So that's my clue that I need to turn this sine into a cosine. How am I going to do that? Well, we need to pull up an identity that we have from a previous video. We need to use the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And there's two ways to do this, I think. One is maybe a little bit more clever, I guess, and the other is, I think, just it's more procedural. Like, here's the procedure, try this. So we'll go with that one. If you would like to see a video of the other version that is maybe a little more clever, I can do that. Just let me know, email me, put it in a comment. Maybe I can do that. So I'm going to take this equation, and I want to get rid of this sine squared theta. So I'm going to take this equation and solve for sine squared theta. Okay, and then I'll be able to make a substitution. So I'm going to subtract cosine squared theta on both sides. So sine squared theta equals 1 minus, cosine squared theta. And I can make that substitution. So this will get replaced with 1 minus cosine squared theta. I just need to make sure that I use parentheses as appropriate. So 3, and I really should, I guess, write an equals here because this is equal to the previous line. 1 minus cosine squared theta, right, plus 4 cosine squared theta. Okay. So now I can distribute this 3 across the parentheses. So 3 minus 3 cosine squared theta plus 4 cosine squared theta. And now I can combine like terms, right? I have some negative cosine squares and I have some positive cosine squares, so I can combine like terms, and I'll get 1 cosine squared. Is of course negative 3 plus positive 4. So I get 3 plus 1 times cosine squared theta. Hey, that's what I wanted. That's it. Um, that's the result I was going for. That demonstrates the identity is always true regardless of the number that you pick for theta.